Hello everyone, this video will talk about the code inside this tic-tac-toe game. Now this is a fun challenge and it's designed for anyone that has finished the exercises and wants to go a step further. It covers most of what I would say all of what we've talked about so far, and there are several constructs that we haven't covered, which I'll explain just a little bit. But the challenge here is to try and figure out or try to understand how this program is playing tic-tac-toe. Now, if you're not familiar with tic-tac-toe, watch this video to see how it works. So the code is over here, and you will have forked it and downloaded it. I'm just calling it tic-tac-toe version 2. I'm calling it version 2 because I got this code from this website, cprogrammingnotes.com, and I've tried to there were no comments in the code, and I've tried to simplify it in some places to make it well, to understand it myself first, and then to make it easier for you to understand it. Now I'm just gonna let's just run it so you can see what this program looks like, or what the output looks like. So here is our tic-tac-toe board, and each square has a number. There are two players. Player 1 is going to use X's on the board. Player 2 will use zeros or O's on the board, not 0, O. So the idea is you want to line up your X or your O across a row or down a column or diagonally. If you do that, you win. If neither player can achieve that, then the game is a draw. So player 1 selects a number, and all game strategy usually involves controlling the center. So I'm going to pick square 5, and there it puts the X in there. Now let's say player 2 wants to go for square 3, so I enter a 3, and there's the 0. Notice if I enter junk in here, such as that's obviously not a number. I press enter. It doesn't crash like we saw in earlier games. It doesn't report an error message. It just repeats the prompt. So now player 1, I'm going to pick square 2 to block player 2 from going across the top row. So I pick 2, and there I've got 2 X's. Now let's assume that player 2, the 0 guy, is not so sharp, and by mistake he doesn't see that I'm close to winning, and he picks square 6, and he thinks, oh look, I'm about to ready to win. But no, player 1 is going to pick square 8, and player 1 wins. Now notice also the bell rang. That beep you heard on a win. You can control the bell on the computer, and I'll show you how to do that, where that's done in the code. So let's just close that, minimize the output. I'm just going to point out a couple of things. I'm not going to explain all the logic of the game. That's for you to dig into. Now, I added these 3 lines, 9, 10, and 11, to define, to make the code read more like English. And you can do this. This is another preprocessor directive. Notice it also begins with a hash. So include and define are preprocessor directives and not C language statements. So instead of having these 1s and 0s and -1 in the code, I would rather refer to these names, which makes the code more readable. You'll see these later. And you can define you can assign a name to a number like this. On line 13, we have an array of characters. What's an array? Well, you can think of it as a collection. It's not a single character. It's a collection of, in this case, 10 characters. So the name of the array is square. This is the dimension. So this is a one-dimensional array. We haven't talked about arrays, but this should help you understand them a little bit. So in this case, I've initialized it, and I have 10 characters in the array. Here are the 1 through 9. These are the characters used to draw the square numbers when the board is displayed. Now, I'm still studying this code. I don't know what they're using this O for, because it's not displayed on the board. This is a different O than the one that's displayed when a user makes a choice. Here are two prototypes for getting the status of the game at any given moment, and this is for displaying the board. All right, now most of this you've seen before. I just want to highlight a couple of things. Now, here is this is similar to what we've seen before for validating the data. Now, the user is supposed to enter a square number. And if they enter something silly, such as DOG or something non-numeric, then we want to detect that and flush the buffer. And so if the result of the scan is a 0, then we're going to set the choice. Let's see. Excuse me. Choice is the variable where we're going to store the user's selected square number. So we're going to set it to -1, which is impossible. We flush the buffer, and then we go check and see what the choice was. Now, it wasn't any of 1 through 9, so it must be invalid, which it is. And yeah, this variable player is how they toggle between player 1 and player 2. I'll let you have a go at that. Now, the other thing this program uses is a do-while loop. So here's a loop. It begins on 25, and it starts with do, and down here, the end of the loop is the while statement. This is similar to a while loop, except that the body of the loop is always executed at least once. With a while loop, the body of the loop may never be executed. If the test in the while loop is false, the first time it makes that test, then the body of the while loop would not be executed. But there are times when you want to execute the body at least once, and then check to see if it should continue. And that's what this is doing. So this is, if you want to Google this, just Google while loop compared to do while loop. Now, I'm not going to explain all the code, so I want you to have a go and see if you can decipher this. Now, what else do we know? What else is new? Now here's where he's accessing the array, and in this function, this is where he checks to see if anyone has won yet. So he checks for a winner, checks to see if the game is a draw, or he checks to see if the game is still in progress. And down here is where they display the board. They refresh the screen. Now, there's one tricky statement here. This line 128 is part of the original code. And this is a system call. System is a function in the library, and they were trying to pass this command. CLS means clear screen. And it's not working in this environment. I think this works in a Windows terminal, but it's not working in it's called POSIX. POSIX, I'll spell it. POSIX. POSIX refers to Unix and Unix-like systems. So there's Unix, there's Linux, and there is, what's the other one? Unix, Linux. Oh, and there's also Mac OS. Now, Mac OS is based on it's called FreeBSD. BSD stands for Berkeley Software Distribution. This was a very early fork of the Unix. So POSIX refers to Unix, Linux, and BSD, Berkeley Software Distribution. You can Google all these things and you can read about the history. It's very interesting, and this is the counterpart to Windows. This all came before there was a thing called Windows, and this is where power users got their start. And so there was this thing called BSD, and Berkeley, I don't know, I think they open sourced it, and they created a free version, which they call FreeBSD. And Mac OS is based on this. So we say that Mac OS is also part of this POSIX environment. Anyway, that's a long-winded way to explain why this statement doesn't work. So instead, I did a little Googling and I found this. And this is how the screen is getting cleared. So when the board is displayed, it is not scrolling a new board. It's writing the new board or the updated board on top of, or it's writing in the same place where the previous board was. So it clears the screen and then displays the board. Now I'll let you try and figure out this code here. Now I'll just put this, I'll just leave this in here just for kicks. I'm going to save that later. Now I'm just going to POSIX. You want to, in your spare time, if you're interested in this kind of thing, Google it. It's really interesting stuff. So I think that's about it. Those are the items which those are the things we have not talked about in class. Arrays. What else did I mention? Yeah, it's mostly the arrays. Here's the flushing the buffer thing, which we've seen before. Oh, one other thing. The ternary operator. You can see it on lines 29 and 30. Let's start with the one on 30. This is a shorthand way of doing an if-else statement. So it's going to evaluate this expression. This expression will either be true or false. And that's the question. If it's true, then assign x to the mark. This is the variable which contains the mark or the notation to add to the board. So if this condition is true, set mark to x. Otherwise, set it to 0 or O. That's an uppercase O. It's not 0. In the same way on line 29, it's doing a mod on player 2. So if the current player is 2 and you mod that, you're going to get, this will evaluate to 0. Now, in C and Java and other languages, 0 is considered false. Anything non-zero is considered true. So this expression evaluates to 0 if the variable player equals a 2. And because it's 0, it's false. So it's going to assign, is that right? Let me see here. If this, let me see, if player 2, so if the current player is 2 and you mod that, you get a 0, which is false. Yeah, that doesn't seem right. I think I might have this backwards. Here I said if it's true, you use the x. So if this is true, meaning O, non-zero. Right. So, for example, this is player 1 and you mod it by 2. Well, the remainder is not 0. The remainder is going to be 2, which is considered true, and so it swaps the player from 2 to 1. Guys, if that's a little confusing, do a search on ternary operator. You do it right now. I think it's called ternary. Let's see. Ternary operator free cocamp. What is ternary operator with? Here we go. Ternary operator in C. And they're going to show us the example. And right there, you can see it here. So you can Google this, and here it's saying this function is going to return the maximum of these two numbers. So it just checks if A is larger than B, well, it's going to return A, otherwise it returns B. So this is a nice, clever, shortcut way to save several lines of code. And once you get comfortable with this, you'll love this operator. Power users use this all the time. And just like anything else, after you've seen it enough, it'll look perfectly normal and you'll be comfortable using it. So have a go with the rest of the code. See if you can penetrate what's going on here. All right, that's it for now. Cheerio.